All right, one of the things I want to cover again, just very, very briefly, a couple of things actually, is how to write the textbook perfect version of the dot equals method. And when I say textbook perfect, I mean not according to this textbook. So to do that, it needs to do a couple of things. It needs to check to see if the address is the same. If the this reference is equal to the other reference that was passed in. That's the first thing it needs to do. Because if it is the same, you can just immediately return true, right? Because that's saying, is Jeff equal to Jeff? Yeah. So if the address is the same, then we know they're the same. Then the next thing we need to do is to rule out that they are of different types, right? If I try to compare a car to a bug, not a Volkswagen bug, right? Car to a cat, it should return false immediately. And there's a keyword that lets us do that. And then and only then after that should we start checking the individual members. So we can do that. Let's demonstrate that pretty easily. I'm going to create a new lecture. I believe we're on, did we say we're on G or did we say we just did G and we're on H?
We just did F, so this is G.
All right. So if you want to avoid putting everything into a package, while you're creating it, you can delete everything up to and including the dot where it says main class. If you do that, it doesn't add the package statement. And I'd kind of like it if you did that. No biggie. Just makes it easier to move around in if you don't have your things tucked in a subdirectory. Okay, so again, we're going to do the point class or something like that. Class P point. Or just PT for point. That's pretty lame. It's going to have two components, an X and a Y. And we're going to add a dot equals method. Dot equals needs to return true or false. So Boolean equals, and what does it need to? Last time we did it, we made it accept an object of type point or whatever. This time we're just going to accept a generic reference. Everything inherits from type object. Every class you create, every class that comes built into Java, they all are ultimately, quote, objects. They all inherit from the same root class. So if you define your parameter as type object, then this method can accept any kind of data without error. Okay. So the first thing we need to do is to check to see if this is equal to the other. And if it is, then that means it's the same object and we can return true. So if this equal other, then return true. Now we need to check to see, to make sure that other is a point. Because if it's not a point, we know that they can't be equal to each other. So if, parentheses, other instance of, this is our new keyword, instance of, PT, capital P. So if the other is an instance of the point class, that's how you read it, right? If the other is an instance of the point class, equals false, or if we just put a not in front of it, right, like this, I think that'd do it, but I'm going to say equals false. Because if this is not a point, we want to return false. So wouldn't it be neat now if I could start checking X and Y and I could type other.x and stuff like that? Well, I have to cast this to a reference of this type object. And we're a little ahead of ourselves yet because we haven't talked about inheritance. But I just want you to see this so that when we loop back to it, it'll make instant sense. So we need to create a point reference and make it from the other reference. That sounds weird, right? But we're going to make a point reference, and I'm going to call it that so that we have like this and that. So PT that equals parentheses, capital P, lowercase t, other. What this is saying is take this reference and recast it to be a point so that we can access all the members, so that we can get a hold of x and y. And now we can do if this dot x equals that dot x. That kind of thing. If this dot x not equal that dot x, return false. If this dot y not equal that dot y, return false. Okay. And if all of that other stuff didn't kick us out, then we know that we have an exact match. We can return true. Now what have I done wrong here? Why does it give me a hint? I mean an error. Because I didn't make it public already. And if I was going to write this completely, I would make those private and I would encapsulate them. I'm going to leave that off for now because this is the important thing out of it. And last time we wrote a copy method, it turns out that you inherit what's called a clone method that you can use to perform what's known as a shallow copy. A shallow copy just copies all the references, all the instance variables, and a shallow copy would work great for this because, you know, all it's got is primitive data types. But if your class has reference types, if it has other objects in it, then a shallow copy is not a good idea because you just wind up with two references to the same data. And so you have to perform a better copy than that. I'm not going to revisit that topic though. Let's go ahead and hit chapter 8. Well, I guess we could create two objects and compare them to each other, right? But we haven't even made a constructor for them. Why not? So public, capital P, lowercase t, and it's going to accept int x, comma, int y in parentheses. And it's going to set this dot x equal to x, semicolon. This dot y equals to y, semicolon. Close curly brace. Now we have a constructor. There's a little symbol out here. Warning. Multiple annotations here. Overrides method. Well, why? I did not mean for it to do that. Add the @override notation and generate the missing hash code. This one sounds good. Add the @override annotation. What that means is that we did get dot equals exactly to what it needed to be to override the dot equals method that the object class gives us. It's just a marker for that. I'll explain later once we're talking about inheritance what this keyword actually means, that annotation actually means. But we don't need it. It'll compile without it. Now it was giving me something else too. I'm going to click that and check to see what it's trying to do. I don't want that. Get rid of that. All right. All right, so I'm going to make 2 points and compare them. PT space P1 comma P equals new capital P lowercase t 2 comma 3. Capital P lowercase t P2 equals new PT 3 comma 4. And then we can compare them. If P1 dot equals parentheses P2, close parentheses, they are the same. Why don't we just print that value instead, right? So system.out.println parentheses quote P1 equals P2 question mark space end quote plus that business P1 dot equals parentheses P2 2 close parentheses semicolon. So it'll run and it'll print that message and it'll print true or false based on whether they're the same or not, and they're not, so it should print false. That's true. That's what it did. P1 equals P2? No, false. All right, so this is the canonical way of writing an equals method. If you're not going to be comparing objects, don't bother. So, software engineering, chapter 8, coding, style conventions, helper methods, encapsulation. Oh, something else that somebody mentioned. Troy mentioned this. If you have a static variable, can you get a hold of it with the this reference? If I do static int, and I don't know what this is supposed to be called, so I'm going to say z equals 0. Can I reference that with this? Can I say this dot z equals 8 for whatever purposes? I'm going to wind up deleting that, right? You can, but it's going to flag it with a warning, because this exists outside of the object. It's like, what if you had apartment objects? You had a whole bunch of apartment objects, but they all shared the same pool. Well, you don't have a pool inside the apartment. The pool is outside all of the apartments. So the pool is static. It's a class member. So you don't refer to it by the this reference, because that implies that my apartment has a different pool than yours. So instead I would use the class name, capital P, lowercase t. That's what it wants to see. And if I had accepted the fix that NetBeans was offering, it would do the same thing. No, it wouldn't. It offers a million different choices, but the correct one is replaced with class reference. Oh my gosh, I have no idea what these last 4 fixes would do and how badly they would break it. And I'm not going to do that. And it's not letting me click on the correct one. There we go. Right, so pt.z. Now I am going to delete that because we don't need access to it. Right. Just remember, if it gives you a warning that you're trying to use the this keyword to access a static variable, you know how to fix it. So coding style conventions. That's just how you tab your code, how you comment your code. Here's what I do. Here's what the book does. It does this block placement of the curly braces, whereas you could go and put the curly braces on the lines, you know, up above them. You could introduce your variables one at a time with comments rather than doing student S1 comma S2. If you do student S1 comma S2, there's really not any room to put both comments, first student and second student. That's not a bad idea at all. Here's how the textbook separates, just like in a UML, where the top line of the UML is the class name, and then the second block are the variables, and then the last block are the methods. Well, the author's kind of emulating that, with the variables going up at the top above this line of asterisks, and then the methods going below it. I don't care if you divvy it up like that, but I do agree that the constructors should go up at the top. The very top thing should be the variables. And when you do refactor encapsulate, it moves the variables to the bottom. So if you do use refactor encapsulate, cut the variables and paste them back up to be the first thing inside the class. What are all these comments here? Do we have these comments? I need to find a version of the PowerPoint that actually refers to these. This is telling us whether, okay, I've never used the dot matches method. Names must begin with an uppercase letter and have lowercase letters thereafter. All right, this is using something called regular expressions, as you can see up here. And a regular expression is a way to check to see if a string you have matches a specific pattern. This regular expression means here that the first letter has to be between A and Z, and that all successive letters, that's what the asterisk means, everything else has to be lowercase letters. And so if first dot matches that pattern where the first letter is uppercase and the rest of them are lowercase, then the setter successfully works, else it prints an error. It's interesting. Just hadn't looked at that slide carefully enough to see what it was doing. As with all examples discussed so far, methods normally use public. Public methods are considered to be part of the class's interface. However, sometimes you have methods that don't need to be public. Those are called helper methods. They should have the private access. Now, I can't really think of a helper method to add to this. But what if we had, I don't know, we wanted to print some information about this thing. And so we wanted something that would build the string to print. Now really the thing that you would want is to make a two-string method. But just to illustrate making a helper method, I'm going to make it private instead. And so I'm going to call it private build string. Now this is moronic because we should be making it two-string. And what is it going to return? It's going to return a string. And so what does it do? It returns the word PT space, end quote, plus X plus double quote space, end double quote, plus Y, semicolon. And then if we wanted to make a display or a print method, we could do that. But that ought to be public so that we can call it. Public void print. And what does it do? It calls our build string and then prints it. So string S equals build string, capital S. I guess I was trying to follow good variable naming, good method naming there. And then system.out.println S. System.out.println S. So I made the design decision that nobody else would ever need to use build string. Only things inside the class. Now, strictly speaking, I don't really know that that's true, but just accept it for the purpose of the example. So since nothing outside of the class ever needs to call build string, why not just mark it private? Your class may need to do things that the outside world doesn't need to know about. And it may have data validation methods built inside, or special kinds of setters that set things appropriately, or file opening and file closing methods in order to make this class capable of saving itself to a file. That kind of thing. And maybe all those need to be internal to the class to where the external code can't call it. Nobody else should be monkeying around with those methods. Sometimes you do that if the methods have to be called in a specific order. If you write code where you have to call the methods in a specific order, that's kind of not great, because if somebody else is using your class, they may not know that they have to call those methods in a specific order unless they read your documentation very well. And if it turns out that the reason those methods exist in the first place is to only be called by other methods, make them all private. So that's a helper method. This is a helper method. I marked it as private so that it could only be accessed by other methods within the class. There's a related keyword to private called protected. Once we start talking about inheritance, we will probably switch from making everything private to making some of them protected. I'm sorry, I zipped away. By the way, are we all good? Everybody's okay. So suppose you're asked to write a program that handles order entries for each shirt. For each shirt order, the program should prompt the user for a shirt's primary color and its trim color. And then for each color, it should perform the input validation to check to make sure that the input was a W, R, or a Y. Or white, I suppose, red, and yellow. That input validation code is non-trivial because it prompts a user for the color entry, it checks to make sure that it's valid, it repeats the prompt if the entry is invalid, and converts a single color code to a full word. Rather than put all of that code every time that the color selection is needed, we should create a helper method to implement the color selection task. For the helper method, the color selection code only appears once in the program and whenever color selection is needed. Now, I'm not seeing a reason for that to be a helper method yet, so let's look at the source. So here we have a class called shirt. Oh, I see what they're doing. right inside the constructor, they're asking for input. Now, honestly, I would never do that. I would never have my object ask for input while it was in the act of creating itself. But you could, right? And so here our class's constructor is calling some input statements and then setting the colors based on that input. Encapsulation. We've talked about that. If its data is hidden, if it's private, if it's difficult to access from the classes outside of the data class, why is it a good idea? Other classes aren't able to directly access the encapsulated data, so it's more difficult for other classes to mess things up, or for programmers using your class to mess things up, or to save you from yourself so that you won't make mistakes later. So how is encapsulation implemented? Break a big problem into separate classes where each class holds a set of encapsulated data. So if you're writing a car management, for a dealership, maybe you're going to have an employee class and an inventory class, right? And then each one can encapsulate its own data. And the data that they contain should be marked as private. And then break the class's tasks into separate methods, where the method holds a set of encapsulated data. Those data items are called local variables. Oh, by the way, this is a very good point. I saw somebody when they were doing the rectangle class, it was supposed to have a method called getArea that would calculate the area of the rectangle, right? Let's make a class called circle that demonstrates this. It's going to be very, very, very small because I'm not going to make it fully implemented at all. But it's going to have R for radius, or maybe the whole word radius doesn't take that long to type it, right? And then it needed a getArea method. Here's what you do not want to do. Oh, and by the way, that should be a double. Do not add area as a member of the class. Why? Because this should be calculated each time. Why? Because if the radius changes, then area is now invalid. It's stale data. It's not appropriate anymore. So if you have something that needs to be calculated every time it's called, don't stick it in a member variable. Instead, make a method out of it. So public double getArea in parentheses, and that's pi r squared. So return math dot capital Pi times math dot POW radius to the power of 2, radius comma 2, or this dot radius 2 if you like putting the this keyword. Okay. Don't make an instance variable for something that should be calculated. Why? Because when you encapsulate it, there may wind up being a setArea method. It makes absolutely no sense for you to say, okay, here's the radius of it, and oh, by the way, here's the area for it, right? If you were creating a circle object, you would not be putting the area in it, unless it was real important for you to be able to do so, in which case it might modify the value of the radius. But no, all these examples have been based on the idea of gathering one piece of data and then calculating another. And if we wanted to calculate the radius based on the area, that would be an entirely different problem. Anyways, hope that's clear. I had to make a comment to that effect when grading. So declaring data as instance variables within a class is one form of encapsulation, and creating data as local variables within a method is another form of encapsulation. What's the stronger, the more hidden form of encapsulation? Well, if you make a local variable, it's safe from all other methods in the class. So like if I came in here in dot equals and I created some dummy variable like, xyz is equal to 10, whatever. That xyz is not available to any other method in the class or anything outside of it. So that's the most encapsulated. If I calculated area here and then returned it like this, double area equals math.pi, and then return that, right? Well, at least that variable is totally protected, right? Nothing else can ever change that variable. And it's being calculated and returned every time. And I guess I was in a hurry, which is why I typed it all in one line. Normally I would do it this way. Why? So I could put a breakpoint here and watch it get calculated. What's a breakpoint? A breakpoint is when you set a marker in it and then you run it in debug mode. Debug this project. And if I ever called that method, it would stop at that point and let me inspect the values of everything. I never did, but I do call dot equals, right? So I could set a breakpoint right here. And then when I run it in debug mode, debug the project, once it calls dot equals, it's going to hang there, right? It stops there so that I can check the value of things. So for example, what are x right now? Looks like x is 2 and y is 3. What about the other? What is that? Oh, well, that's just purely a reference. We don't know what it is yet because it hasn't been cast. Well, let's see if this comparison returns true or false. So I'm going to step over that comparison. Well, it didn't return, so that was not true. That one didn't return, so that's wasn't a trigger for it. Didn't return false. How about now that we've done this? We took other and cast it to be a that. Now when we click on that, we should be able to refer to the x and the y variables that are in it. And so the x and the y for the other object are 3 and 4. And the x and the y for our object are 2 and 3. See how cool the debugger is? I really ought to make us use it for 2 weeks in a row just to get really familiar with it, because once you're a professional programmer, you're going to be using debuggers an awful lot. Okay, that's enough of that. But if I had put a breakpoint here, then I could watch this get calculated before it got returned, right? So I would check its return value before letting it skip past that statement. And if it was wrong, and I'd just press the red button, stop debugging, and fix it right then and there. So when do you declare things locally within a method? If the variable only needs to remain alive for the duration of that particular method, make it a local variable. Like area in that case, right? Only that one method needs to make an area method to return it. Nothing else does. Like any setters, right? Set radius doesn't need area method or an area variable. When do you declare that variable as an instance variable? If it stores a fundamental attribute of the class's objects. The circle has a radius, so that's part of its class. A circle also has an origin. It has a center. We could make the point class a member of the circle class. We could do this. PT space origin equals new PT parentheses. I'm going to just run with this, right? We don't even use our circle class, but now we have an object that's part of another object. It's called aggregation. Aggregation is when you make an object that contains objects. And we will be talking more about that in the next chapter, I believe. No, the next chapter is arrays. So we will review arrays and get into them more in depth than you might have in Intro to Java. Now that we've done that, that involves a whole new ball of wax, right? Because what if we wanted to change the origin? What if we wanted to be able to, say that this point begins at an entirely different place? Well, we probably add a constructor that accepts both the radius and an xy coordinate for the origin. I don't feel like fluffing up the circle class that much. You know what? I'm just going to delete this. You've seen it. Now you see it. Now you don't. If the variable needs to persist for the duration of the class object's life, if you need that piece of data for as long as the object exists, it ought to be a class variable. Excuse me, an instance variable. Algorithmic design with OOP, object-oriented programming. Given a problem description, what steps should you use? When I'm thinking about a problem, I think in terms of what kind of data it needs to hold. I'm going to write a billing program for somebody. Well, I need to know what they are ordering and who to bill. That's two entirely things, right? What they are ordering is a series of purchased items, So maybe now we're coming up on 3 different things we need to be able to track. We need to be able to track the person, and that person has an address, right? You know, maybe credit card information, something like that. And then there needs to be a inventory item class, and then there needs to be an order class that contains a list of inventory items and a reference to a person that ordered it. So for each class, you pick its instance variables. For each class, you pick its public methods. And for each method, you implement it using top-down design, meaning you think about what it needs to do first, what it needs to do second, what it needs to do third, and so on. So in writing a public method, if the method is fairly involved, you try to break it into subtasks. Right? A general rule of thumb is that by the time your block of code is like more than a page worth on the screen, of course people have pretty big monitors nowadays, right? But you know, by the time it's 50 lines of code or 100 lines of code or whatever, see if you can break that one up into sub methods. Just because when something gets too large, it's harder to understand it. And then if you can break it up into simpler tasks, then you can guarantee that those tasks work better. You can focus your testing on them, make sure that they work. Stubs. After writing your entire program in pencil or paper, enter your program on a computer using stubs for your subtask methods. Stub is a dummy method like this. All it does is print something. So like, what if I know that my circle class needs something that will set the radius of it, or set its position, right, or set the color of the circle? I might just create some stubs for it. Set color, parentheses, string color. I haven't even implemented what that means. So all I'm going to do is put a print message. Set color called. Space end quote plus color. Right? Just like that. That's all it needs to do. I might put the word debug in front of it to indicate that, you know, that's just a debug message and it needs to be fixed later. So this is a stub. It's something I'm going to go back in and fix later. Why do you use stubs? You need to get your program in a functional state as early as possible. It doesn't have to be working. It doesn't have to do anything, but it has to be in a functional state. The sooner you can get your code to compile and run, even if it doesn't do a darn thing, the better off you are, because then you can make a change and run it, and make a change and run it. If you sit there typing in like 500 lines of code and you've never compiled and run it, you're getting into a bad situation. Because when you try to finally compile it, it's going to have, you know, 20 syntax errors, and then you're going to find out that you made some design mistakes, and you know, kind of called the snowball method. You start with a little tiny piece, like a snowball, and then you keep rolling it, and it gets bigger and bigger and bigger. Just like when we're creating these things during our lectures. We start small, and then we keep adding something to it and compiling again, and adding something to it and compiling again. Now, we're not starting out with a preset course, right? I haven't drawn out an algorithm, you know, a list of things that these things need to do. I'm just rattling them off the top of my head. But you get the idea. So we have set color, and what if we had a set position that was supposed to set an XY position for this circle? Well, we haven't even implemented anything like that, but we could still add the stub for it. Void set XY, right? And then it could take 2 variables, double X comma double Y in parentheses, and all it has to do is print another debug message. Doesn't have to do anything useful yet. Print line, parentheses, quote, debug dash set XY called, and then if we wanted to, we could print out the values of X and Y, in which case I probably should have made it a printf. But anyways, plus X plus a quote space quote plus Y. All right, we've made the circle class so big that we probably ought to go down to main and at least create an object to prove that it works. So I'm going to scroll down to main. down here I'm going to make a couple circles, right? At least one. Circle C1 equals new circle. And then C1 dot set color, quote, red end quote, right? C1 dot set XY in parentheses, and I want this to be at 10, 5. And now when it runs, I will see that it did those two things. And it did, right? We see the stub messages. We see the debug messages. If you reference something that's not actually part of the class, like I did this, like if I accidentally type in something, C, that's not set, that's not created yet, C1 dot set name. Every circle is supposed to have a name, right? I have not added a name method. I could sneak over here and say, please create that method for me. If I do that, and then I go back up to the circle class, I'll see that it's there. But it's not a stub like we did it. It's a stub designed to crash when it's called. It'll crash with that error. Then you're supposed to fix it, right? To make it not crash. I'm going to go back and I'm going to delete that. I just wanted you to see that. All right, so I deleted the that method, and I'm deleting the call to set name. The benefit of stubs. If the program is initially created with stubs, the programmer will be able to more easily get an initial successful compilation, which leads to a warm, fuzzy feeling. Well, it's not that I want a warm, fuzzy feeling. It's that I want to get it to a working state as soon as possible so that each change I make doesn't break it. And then debug is easier. After the program is compiled and run, the programmer starts replacing the stubs with actual code, one method at a time. Ideally, after each method is replaced, it's thoroughly debugged, because all you did is you added a single method, and you can run it as many times as you need to test that method. That way, when the bug appears, you know where it was, because it's probably in the last method that you added. Merging the driver method into the driven class. So far, we have always split our stuff into two classes, the driver class and the class that it is driving. You don't gotta do it that way, but I strongly recommend not doing what I'm about to show you. What if this main class, this Lecture G class, was really, really cool? It had a whole bunch of pieces of data. It had some instance data that I wanted it to be able to use. I can't think of any, so I'm just going to make one called string name equals, Bob, whatever. If you wanted to be able to use this lecture class as though it were an instance, go ahead and do that inside main. You create a new instance of your lecture. Lecture G, LG equals new Lecture G. And then you need some hook, some way to get this thing to start running, like lg.run, parentheses in parentheses. And you would put all of this main code inside that run method. Why not? Why don't? I'm never going to do this again. You're never going to see me do this again, and I don't want you to start doing it until we start talking about multi-threaded applications. That's the only time we're going to do anything like this. But if I cut this code and I make a new method called run, public void run, parentheses in parentheses, and I paste all that stuff, there we go. Now main is driving itself, right? Main creates an instance of itself and then calls a run method on it so that it can actually start doing things. And if it wanted to, it could create a second instance of itself. Main could create 30 different objects of type Lecture G and call run on each one of them. Really don't know why I would want to do that, but I could, right? I could say LG equals new Lecture G. Now we have a second object. And I could run that one again. Now all of our code is going to iterate twice, right? We're going to see all of our messages doubled up. I'm probably going to delete those next two, or at least comment them out. But for now, we'll see. Right. Each instance could have its own name if it needed to, because Lecture G is now got instance variables in it, one in particular. Hope that makes sense. Get rid of those. So one thing that a lot of people do when they're taking these Java programming classes is if the program involves something like a circle, they call their project circle. And then they create a main Java class called circle that has a main method in it. And then they start wondering where they're supposed to stick their data about it. Where do I put my radius? So they go ahead and add that to the circle class. And it becomes a mess, right? Because circle is both the driver and the driven class. It's both the client code and the code that, that it's using. Well, you can get it to work that way, but I strongly recommend that we separate our data classes from the driver, like we've done every other day we were here. And here's what they're showing. They have a class called time, and then when you compile and run it, there's a main in here that creates a brand new time object and calls printed. Accessing instance variables without using this. For a while we've been using this to access instance variables, but you don't have to. In my get area method up in circle, or here where I was calling this .x versus that .x, I didn't need that. Don't delete them because I think it's much better to have them there. I didn't need that. If you think that's cooler, if you like the way that looks, go for it. When do you have to have this reference? When you have a parameter of the same name, right? So that's why this .x is absolutely necessary, because if I removed this reference there, no longer is any of them green, right? Because x equals x, well, I'm just setting the parameter equal to itself. I'm not comparing it to that data. So that would be a terrible mistake. While I'm here, I'm going to tidy this constructor up a little bit. I'm even going to add that this is a parameterized constructor. And what do parameterized constructors do? They have parameters that set the instance variables. At least some of them. Maybe some of them don't need to be set. I'm going to go back down and re-add this reference down to those things where I took them out. But if you want to avoid using this reference for everything except when you absolutely have to, like in the setters or constructors, then feel free. Like we had to get area up here, I did not have to do, oh, see, I did it that time. We have a variable called radius, and I did not call it this .radius, which is totally valid. It's what I usually would have done, but I didn't in that case. I left it out, and that's okay, because it's not referring to a local variable. Now, if I did have a local variable named radius, for whatever horrible reason that I felt like doing that, and then I did not use this reference, well, now it's turned black, right, because it's referring to that one. It's not referring to this one. So I'd have to have this reference to get that to work. All right, if you were making all these changes, I am reverting them back to how they were, except I'm changing this to say this .radius. So if you feel like making that change, go for it. If not, that's fine. That's unlike Python, by the way, where if you're going to use an instance variable, you have to precede all of them with self dot. That'll only make sense if you've actually taken scripting. Quiz questions. When the book explains helper methods, what sort of program is used as an example? Well, I'm not going to open the book and find out. So I'm sorry, I'm not answering question 1. For a given program, it is legal to include a main method in any class, just in one class, and that class's name must end in driver. Well, that's silly. Just in one class, and the class must be an anonymous class. Well, what the heck? We have not talked about anonymous classes. That kind of means it's in any class. And honestly, you can have 20 different classes with a main method. You would just have to go and modify your project properties to indicate which one really is main. Right, I could come over here and right click on it and choose properties. And then one of these things over here, when you run it, you pick what the main class is. And if I had 17 different classes all with main methods, then when I click browse, I'd see it. And sometimes you'll see that. You'll run it, and for the first time, it'll ask you where your main method is. So yeah, you can put the main method in any class that you want to. Ooh, see, lots of useful quiz questions. What's the real takeaway on this? Do think in terms of encapsulation. It's a very good thing to be thinking of. What else did we cover? It's really, really important. Helper methods. Make them private. If you have a method that's only called inside the class, make it private so that other code can't call it, so as to prevent yourself or from somebody else from messing up. That's what a lot of programming is about. It's just preventing you from goofing up. Because the more the compiler does for you to stop you from goofing up, the better off you are. Coding conventions, we have talked about those before. Stubs. That is an important concept, right? Get your code working as soon as possible by using stub methods if necessary to kind of create a skeleton, and then start filling in, adding the flesh to the skeleton. And that's enough for today. And I don't see any reason to create any additional homework over this, because the only concept I've honestly and truly had not covered before is the idea of stubs. And I just want you to use them when they're useful to you. I'm not going to make you write a program that has stubs, because one with stubs is a half-finished program, right? And how to create the proper .equals method. And we'll hit .equals again maybe when we start talking about inheritance. So I'm not going to make you memorize that and do that right now. One of your homework assignments is to create a .equals method inside of a class. And if you feel like doing it like this, so much the better. If I notice you doing it like that, then you can get some extra credit for having implemented a perfect equals class. If you ever add something that you think is worth extra credit, please add that as a text comment to us so that when you upload it, I'm looking forward to, because I don't always remember to check everything and go, well, yeah, that is pretty cool. And I do give extra credit. If you try to put in extra work, feel free to ask for the credit for it, right? I made this save to a file even though you didn't ask for it, right there. Let me know, and I go, hey, yeah, that's cool. Extra points. All right, so let's stop here for today. Any questions? Did everybody get it working?